Time to goggle up. We're gonna do some amazing math. Oh no. Did it leave a mark on my forehead? That ain't gonna work. Okay. Well, let's see what we can do today here. Here's part 2. Are you ready? So I'm gonna start with what's called a parent function. Parent function is like the starting place for everything that is that same shape as that function. And here it is, 1 over x, the inverse function. And we, in the last episode, we looked at that general shape like this right here. That there are some general characteristics of that function, that it tends to toward 0 as x tends to infinity. It approaches 0 on this side, it approaches 0 from that way. It has a horizontal asymptote at y equals 0. We also saw that general shape, the curve there, that inverse relationship that we explored a while ago, and the fact that once we hit x equals 0, we've got a problem, because that would be, we'd be trying to divide a number by 0, which we cannot do in math. So what we do is we draw like a dotted line to indicate that there is a vertical asymptote, is the word. And for the parent function, it's at x equals 0, or along the y-axis. Now what we're going to do now is we're going to just take that basic starting point and then we're going to change a little bit. Maybe we're going to multiply that equation by a constant. Maybe we're going to subtract something from x first before we do the rest of the math, or add something onto it later. That's going to take that picture and move the whole picture maybe to the left or to the right, or change the stretchiness there of that curve, or move it up or down. And what we want to take care of is the general characteristics of that shape, that all the things that were true of that parent function then shift in a certain way that goes along with what we've done to the whole picture. What I mean by that is that if we add 1 to the whole function, like add 1 over x and then plus 1 outside, if I do this, or actually I'll just do minus 1 outside, not part of that fraction but just out there by itself. I'll draw it a little bigger here, minus 1. Then we'll take our shape and we drop it down 1, so that instead of the asymptote being at y equals 0, now our asymptote is at y equals -1. The rest of the shape is exactly the same, except the whole picture has been dropped down 1 unit. But the vertical asymptote is still where it was. The horizontal asymptote has been dropped down from y equals 0 to y equals -1 because we did that to it. So I'm going to introduce to you a thing, if you need to write this down in your notes, the general form here, and we're going to put in some letters just as placeholders. We're going to have the letter A, letter B, and the letter C, and you need to make sure that the A is on top. That's going to be our multiplier, our scale factor. If A is 2, then we stretch it out twice as much. If it's 3, we stretch it out 3 times as much. B is going to be the shifting that we're going to do to the left or to the right, and the form is always x minus whatever shift we do to the left or to the right. And then C is going to be the shifting that we do up or down. And note the form is plus C. Here's another way that this gets written. You can just write this down as an alternate version of it. A, again, our scale factor. B is another type of scale factor. We have then x minus h for horizontal shift, and then k for covertical shift. That's for whatever reason in math they always do covertical and horizontal. For our original parent function, we had a vertical asymptote and a horizontal asymptote, and now because we've got these special kind of placeholders here, our vertical asymptote is always going to be at x equals h. And our horizontal asymptote will always be where y equals k. Or I guess up here in this form, we can say when x equals b and when y equals c. Those are both true. Remember, vertical is up and down. Horizontal is this way. We called that also a limit. Another math word that we got there. So I'm going to go over to the table and pull up my calculator. I'm going to show you the one function that I've built with sliders, and we can actually watch the picture change as I change the values of A, B, or C. Okay, you still there? All right. So I got my graphic calculator out here, and in Y3, I want you to show you I've got 2 over x minus 3. So in this case, my value, let me do it this way. My value for A in that general equation is 2, and my value for B is 3. It's not negative 3, it's 3 because the form is x minus b. And then for C, there's nothing outside. It's plus 0. So C's value is 0. Now, again, we should be able to predict the shape. We should be able to predict the asymptotes. The thing said that the asymptote is going to be, well, let's see, when x equals 3. Is that correct? So we should see it shifted a little bit. And then, whoa, goodness sakes. We should also see no shift in the other direction. So I'm going to go ahead and graph that one and see what we get. So there it is, y equals 0, and then we see that the whole picture has been shifted over to the right, and that's at 3 places. So that if I trace this thing at 3, it should not give me any answer because there's a vertical asymptote or a dotted line. And then again, if I scroll this way, you'll see that the value for x is getting smaller and smaller and smaller and is tending towards 0. That's its limit as I go to the left, or sorry, to the right. And if I was going to go to the left, we'll see the same exact thing. It goes really big positive, really big negative, and then it's as we head to the left, y value is getting smaller and smaller and smaller and smaller. Okay, so that's what we should expect when we have a thing like that. And if I compare that to the original, it's not as curved. It's a little bit less curved. So A was 2, and B, we saw that shifted the whole picture to the right 3 places. Once you see what would happen if I did this, if I made it plus 3, just make a prediction, and then here we go, and here comes our line, and now it's on this side, and it's been shifted to the left 3 places. So I'll show you that more on my other calculator, but I just wanted to get this kind of out of the way. Now the other function that I had kind of put in here, and let's turn that one off, is this right here, and it kind of looks silly, but I just kind of put some numbers in there as placeholders. I got 1 for A, I have 0 for B, and 0 for C. So if we follow that asymptote rule, the asymptote rule was that when x is B, then we have our what? We have our vertical asymptote, and when y equals C, we have our horizontal asymptote. So in this case, B is 0 and C is 0, so we'll have asymptotes at x equals 0 and y equals 0, because this is basically the 1 over x equation anyway. So if I turn that one on and we graph it, it looks exactly the same as the parent function, 1 over x, because it is. I just put those placeholders there for me to fiddle with it. Okay, that's all cool, but this is cooler. I've built a function on my TI Inspire with these little things called sliders. They're over here, and I've got the general form over yonder. F of x equals a over x minus b plus c. And then I just ask it to let me change the value for a, b, and c as I go. So right now, the value for a over here is 1. I'm going to grab that thing, grab it, grab. Okay, and I'm going to increase the value of a, and you can see how that changes the function. The curviness of it is kind of not as curvy. It's not really moving it left to right, up and down. It's just changing the curviness of it. So if I go this way, I get a very low curviness, 0.5, and if I increase it, I get less curviness. So I'm going to put that back at 1 so we don't go too funky here. And now I'm going to go and I'm going to change 8. Leave it. Okay, I'm going to go and grab this one here. Grab. And I'm going to increase b. So I'm going to increase that value. There's going to be x minus a bigger number. X minus 1, x minus 2, x minus 3, x minus 4, x minus 5. And you can see what's happening there. The picture is shifting to the right. And if I move my slider this way, the whole graph moves that way as well. So that value for b controls our left and our right movement of the thing. And that moves the asymptotes. It moves them to whatever b is equal to. And I'll move down here to c. And you can see where that is on the thing. It's just outside of the fraction. And so when I move that, you see that the whole picture moves up. If I increase c, and the whole picture moves down if I decrease c. So that's the effect of each of these individual pieces in the function. And all I'll do here is I'll go back to my other calculator and we'll put in a couple of values and we'll see what happens. Okay, we'll put in some values into my my form function here. I'm going to do one where a is 4, b is 3. Wait. No, I'll go b is I'll put parentheses here, -1. And I'll make the last one equal a +3. Okay, it'll be 3 in the form. So what do we expect to happen? We know that both of our asymptotes are going to be changing because our asymptotes are going to be when x equals b and y equals c. That's where our asymptotes are going to be. And we already plugged in the value that a is going to be 4, so it's going to be more stretchy. B is equal to -1, and c in this case is a 3. So that means that our asymptote should move. Our asymptote should be at, by substitution, -1, x equals -1, and for this asymptote, it should be at y equals 3. So my graph should look something like, well, where's x equals -1? Right here, there should be an asymptote, and at x equals 1, 2, 3, there should be another asymptote. And then my picture is going to stay the same except be less curvy. So that's what my picture should look like. The axes are going to be here, and my graph should look something like that. So let's hit graph and let's see how we did. Okay, it's higher and it's shifted a little bit to the left, which is what we expect. In fact, here's our new origin, okay? And what do you think the value of that one is? I think it has to do with the shifting that we did. I'm pretty sure that point is at -1, 3. Looks like we did a good job there. Give you one more. Let's say that a equals 1, b equals 4, and c equals -2. Okay, so that means my equation's got to look like this. 1, this is going to be 4, and over here we've got -2. Oops, minus. Running out of time here. -2. So we should be able to predict the shifts around and whatnot. When I hit graph, we see that it's a little bit lower. It's down 2 down, and it's been shifted to the left a few places as well. But shifted, to the right 4 places and down 2, and that's exactly what it says we're supposed to do. So there you go. There's that lesson. We'll see you next time.